variational parameters. This problem, the reason we have to use variational parameters because the kind of the input function we have on the left hand, on the right hand side. If it is e to the t, it will have e to the something like this, sine or cosine or polynomial. If it's like this function, then we don't have to use variation parameters. This one we have cosecant square, so we have to use it. So the first part, we will look on the left hand side. We have the homogeneous equation. Or homogeneous solution. The equation is second derivative plus 25 the function equal to 0. Corresponding to that, we have the auxiliary equation r squared plus 25 equal to 0. From this, we have r equal plus or minus 5i. So we have r equal to plus or minus square root of negative 25 plus or minus 5i. Right? So then we can write y1 and y2. Note that we can write 5i as 0 plus or minus 5i. And for complex solution, we're going to have e to the 0t and then cosine 5t. E to the 0 power is 1, so pretty much just cosine of 5t. And y2 will be e to the 0t, which is also 1, and then sine 5t. So it is just sine of 5t. Right. So we have y1 and y2. Next, we will find a particular solution. For variation of parameters, the particular solution will be equal to v1 y1 plus v2 y2, where v1 and v2 are solution to the system of equation. This is going to be the system of equation y1 v1 prime y2 v2 prime equal to 0, and y1 prime v1 prime y2 prime v2 prime equal to. Now, luckily we have the coefficient here is 1. Then we're just going to use that function. If this is something else like 2, then we have to divide by 2. We don't have to do that on this problem because the coefficient is just leading coefficient is 1. So we're just going ahead and use 4 cosecant square of 5t. Alright, so that is the system of equation. From here, we should be able to solve for v1 prime and v2 prime. And after that, we integrate and we have v1 and v2. Right. To do this, we will use the Cramer's rule. Cramer's rule, we will write on the determinant. W will be y1, y2, w1 prime, w2 prime. W1, for W1, we will replace the last column into the y1, into this column. So we will have 0 and 4 cosecant square of 5t, y2 prime, we stay where it is. W2 y1 and y2, I'm sorry, y1 and y1 prime, we stay the same. And instead of y2 and y2 prime, we will use the last column. So we have 0 for cosecant square 5t, right? So that is on the w's. First we find w will be cosine of 5t, y1, negative 5 of sine 5t, that is y1 prime. Y2 is sine 5t and cosine of 5t. I forgot the 5 here. 2 by 2 determinant. Just multiply cosine 5t with 5 cosine 5t. We have 5 cosine square of 5t plus 5 sine square of 5t is the negative, but on this direction, on the sine 5t and 5 sine 5t, we have to use the subtract. So subtract a negative, turn into a plus. And cosine square plus sine square is 1. So we're going to have 5 cosine square so that will be just 5. Right. Next, we have 0 for cosecant square 5t, sine of 5t, 5 cosine of 5t. Determinant of this, 0 times 5 cosine 5t is still 0. We have minus sine of sine 5t times 4 cosecant square of 5t. Now cosecant square is 1 over sine square. Cosecant is 1 over sine. So we'll have, let's say negative 4 will be on the top, sine of 5t. Cosecant square, that will be sine square at the bottom. And cancel the sine 5t, we just have 4, negative 4, sine, so will be cosecant 5t. Similarly, for W2, sorry, y1 is 5 cosine of 5t, negative 5 of sine 5t, 0 for cosecant square of 5t, right? So the determinant will be 4 cosine square, I'm sorry, cosine 5t, cosecant square 5t. And just like the last problem, cosecant is 1 over sine, so we will have 4 cosine of 5t over sine square of 5t. Alright, so that on the w's, the wrong skins. Then we will find u prime v1 prime is w1 over w. So we have W1 is negative 4 cosecant 5t divided by 5. So that's what we have. So we will write just negative 4 over 5 cosecant of 5t. So that is V. And then we will integrate negative 4 cosecant 5t over 5 dt. That will be negative 4/5. Integral of cosecant is negative ln of cosecant 5t plus tangent 5 cotangent 5t. And then there's 5, so we have to have 1 over 5 for that. So multiply together, we should have negative 4 over 25. Actually, there's 2 negative sign, so that is positive 4 over 25 ln cosecant of 5t plus cotangent of 5t. I forgot the absolute values. Right, so that's what we have for V1. V2, V2 prime is W2 over W. W2 is 4 cosine of 5t over sine square of 5t divided by 5. So put together, we should have 4 cosine of 5t sine square of 5t. Now all of this divided by 5, which is multiplied by 1/5, so we're just going to put the 5 there. And we will integrate this. I will write 4/5 in front. No. And then we have cosine 5t and sine square of 5t. Right. For this one, instead of write cosine 5t and sine square 5t, we can scramble a little bit, and we will write as cosine 5t over sine of 5t and then 1 over sine of 5t. The reason we write like that, so this actually turned out to be 4/5. Cosine over sine is cotangent, and 1 over sine is cosecant. Cosecant of 5t. Then the integral of cotangent cosecant is going to be negative cosecant of 5t. Right. Yeah, integral of cotangent cosecant is negative cosecant of 5t. Except substitution, we should have 1/5 because this is 5t here. So we have negative 4 over 25 of cosecant 5t. Alright, so we have v1 and v2. We can substitute into the form of particular solution. So particular solution is v1y1 plus v2y2 v1 is 4 over 25. ln of cosecant t plus tangent t. y1 is cosine of t 5t plus v2 is negative 4 over 25 cosecant of 5t, and then y2 is sine of 5t. Cosecant is 1 over sine, so we just have those two cancel out. So the solution is just 4 over 25 ln and then minus 4 over 25. Sorry, it's not tangent t, it is cotangent. Sorry, cotangent of 5t cosecant of 5t and then minus 4 over 25. So that is the particular solution. The general solution will be general solution will be the homogeneous solution or the complementary solution plus the particular solution. Or we will write C1y1, C2y2, and the particular solution. And then for our problem, y1 is cosine, y2 is sine, and then the particular solution is 4 over 25 ln cosecant 5t cotangent 5t minus 4 over 25. And that is the solution to the problem. I will zoom out so we have a better picture of the whole problem. So that is the whole solution. Notice that the part that we use on the W's, the part that we use the W's here, that is called the Cramer's rule. And just find W1 over W will give you V1 prime. That's just the derivative though. We still need to integrate to get to V1. And then same thing, W2 over W give you V2 prime. Still need to integrate to get V2. Once we know it, we can put it back into the particular solution for variation of parameters will be in that form. And homogeneous solution plus particular solution, we will have the general solution.